Hello everyone. In this, we will understand about the significance of an observed sample correlation coefficient, which means suppose we have some pairs of data, we calculated the Carl-Pearson's correlation coefficient. Now, whatever answer we obtain, whether that correlation coefficient will be the same even for the sample from where this particular data is being collected. Will it be almost the same, or is it just only a what do you call fluctuations in the sampling? So here, suppose a random sample that is xi, yi, that is pairs of data for n sample size has been drawn from a bivariate normal distribution, and let small r be the observed sample correlation coefficient. The problem is to find if this sample correlation coefficient is significant of any correlation between the variables in the population, or is it just due to the fluctuations of sampling? Professor R.A. Fisher proved that under the null hypothesis H naught, which is rho equal to 0, means rho is the population correlation coefficient. When you say population correlation coefficient is 0, it means that the variables are uncorrelated in the population. So the statistic what is to be used is under modulus t calculated value, which is r times square root of n minus 2 divided by 1 minus r square. That follows t distribution with n minus 2 degrees of freedom. That is, t calculated value follows student's t distribution with n minus 2 degrees of freedom, n being the sample size. Let us understand this with a numerical example. Here, question says a random sample of 27 pairs of observations from a normal population gives a correlation coefficient of 0.42. Is it likely that the variables in the population are uncorrelated? So here we may notice n value, that is sample size, is 27. And then R value, correlation coefficient for the sample, is 0.42. Now, our null hypothesis will be population correlation coefficient is 0, which means that variables are uncorrelated in the population. Our alternative hypothesis will be rho not equal to 0, means it becomes a two-tailed test. Okay. Now, let us calculate the statistic, the relevant test statistic, relevant t-test statistic will be t-cal under modulus is equal to r square root of n minus 2 divided by square root of 1 minus r square. So that is equal to r is 0.42 multiplied by square root of 27 minus 2 divided by square root of 1 minus of 0.42 the square. The whole thing under modulus. So numerator is 0.42 times square root of 27 minus 2 is 25 and square root of that is 5 divided by denominator, after squaring this and subtracting it from 1 and then taking a square root, we get 0.9075. So if we evaluate this, we get 2.314. Now this has to be compared with t-table value, t-tab, which is t-table value for n minus 2 degrees of freedom. Means here it is 27 minus 2. So 25 degrees of freedom at, since nothing is specified about the significance level, we will consider 5% significance level. 5% level of significance for a two-tailed test. This is a two-tailed test, but the tables, what you're going to use is a one-tailed table values. So we have to convert this as t table value for 25 degrees of freedom at 5 by 2, which is 2.5 level of significance for a one-tailed test. That if we refer to the tables, we will get the result as 2.06. Now, based on this, we can infer since Tcal under modulus, which is 2.314, is larger than T-tab, which is 2.06, we reject H0. When we reject H0, we actually accept H1, which implies that we accept H1, which means that we conclude that variables are correlated in population and the R value is significant. R is significant. So that will be the result for this. Let us move on to another example. Here, a correlation coefficient of 0.2 is derived from a sample of 625 pairs of observations. Is this value significant? So here, correlation coefficient for the sample is given as 0.2. So R is 0.2 and the number of pairs of data is 625. So again, null hypothesis, we will be considering rho equal to 0, and then alternative hypothesis, we'll consider it as rho not equal to 0, which is again a two-tailed test. Now, Tcal under modulus will be R square root of n minus 2 divided by square root of 1 minus R square. That will be equal to 0.2 times root of 625 minus 2 divided by 1 minus of 0.2 square, whole thing under the square root. If we calculate this, we will get 5.09 as the calculated value. Now, degrees of freedom is n minus 2. Here it is 625 minus 2, which is 623. Now, the tables, whatever we are having, T tables, it will have maximum degrees of freedom of 120 degrees. Since the degrees of freedom is greater than 120, T table value, T tab will be T table value for a one-tailed test for, again, we consider 5% for a two-tailed, which means 2.5% for a one-tailed. For a 2.5% level of significance will be 1.96. Means T distribution tends to a normal distribution since the sample size is very large. So we can say inference, since T-cal under modulus, which is 5.09, is much larger than T-tab, which is 1.96. We reject H naught. Means we accept H1. Means we say R is definitely significant. So that is the solution for this question.